Hello people, welcome to the title song. So today I'm gonna explain today's LeetCode daily challenge, which is minimum time to make rope colorful. So what is the problem? Let's understand the problem statement. Allies and balloons arranged on a rope. You are given zero indexed string colors, where colors I is the color of ith balloon. Alice wants to rope to be colorful. She does not want two consecutive balloons to be of the same color. So she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You are given a zero indexed integer array. Needed time. Where needed time I is the time in seconds that Bob needs to remove the ith balloon from the rope. So we need to return the minimum time that Bob need to make the rope. So what does we mean by the colorful, the rope to be colorful? Okay. So in order to be a colorful, the rope must not contain any two consecutive balloon with same color. Okay. So the suppose this is our input balloon array, colors of string. Okay. So there should not be any two consecutive uh, balloons with the same color, and balloons is represented by character array. Okay, so suppose there is one there are two consecutive character, which is a and a. So we need to remove either the first one or the second one. Okay, and we need to while removing, we need to maintain minimum number of seconds to remove this balloon. Okay, suppose for removing the third balloon, uh, we are required 3 seconds. Okay, and for removing fourth balloon, we are required 4 seconds. So what we will consider? We will consider to remove the third balloon. Okay, that will take 3 seconds to remove third balloon. Uh, okay, so if we see third example, as you can see, there are two positions where the two consecutive balloons are of the same color. Okay, so we need to remove the either first one in the first balloon or second balloon in the first position, or and in the second position we also need to remove either first or second. Okay, if you see the example, if you see the needed time to remove these all balloons, for removing the second balloon of first position, we will require 2 seconds, and for removing first balloon we will require 1 second. So we will consider removing the first balloon in the first position. Okay, because it is requiring, it is taking 1 second to remove. Okay, and same goes for second position. We will require 4 seconds to remove the first balloon, but we will require only 1 second to remove this second balloon of second position. Okay, so we will consider last two balloons to remove and keep other balloons as it is. Okay, so in the end we need to take 2 seconds to remove these two balloons. Okay, yeah, suppose we have this six balloons. Okay, and the color of this balloon is red. This color of this balloon is yellow. Color of this balloon is also yellow, and this one also yellow. And color of this balloon is blue, and it is white. Okay, and the time is that is given to remove these balloons is this is 7, this is 3, for this 4, for this it is 2. And for this, let's take what 6, and for this 9. So this is the time integer array that shows the all the time that we need to take for removing the particular balloon. Okay, so let's see what we can do. Okay, so this balloon we don't want to remove because uh, it has not any consecutive left or right element. Okay, uh, it has one consecutive element, which is present in the third position. So in order to remove either two of them, what we will consider the first balloon, because it is taking less time to remove rather than removing this balloon. Okay, so we will remove this balloon. Okay, after coming to this position, we will check whether there is any consecutive element or not. There it is, which is the fourth balloon. Okay, so we will compare both the time taken by both the balloons to remove. Okay, so now as we can see, the fourth balloon is taking less time to remove, while the third one. Okay, so we will remove this balloon. Now we will check for fifth balloon. Is it any consecutive balloon with same color or not? There is not. Okay, so we will go to last balloon, and the last balloon is also not having any consecutive balloon with same color. So what is the total time we have taken to remove all the consecutive balloons with the same color? It is 3 plus 2, which is 5. Okay, so the answer should be 5. So let me show the approach. Okay, let me show how we will approach this problem. So we will take two pointers. One is pointing initially. First pointer is pointing to this position. Okay, and we will start traversing the array, or we can say string, from the first to last position. Okay, so we will start traversing from this position, and we will check if the current uh, if the current index if the character of current index is equal to the character of the previous, let's call it as the last index. Okay, so if I the character of present at I is equal to character present at last, we will check whether mm, what is the minimum number of to require either one of them. Okay, so if the current position, the needed time to remove the balloon at present at current position is less than the time needed to remove the balloon present at last position, we will remove the we will remove the current position balloon, and we will not update our last position. Okay, because we have removed the current position balloon, but we have not removed the last position balloon. So we will keep the last pointer at as it is. Okay, we will not change it. So now we will move to another index, next index, and we will check what is the if the present element, the current index character is equal to last position or not. If it is not, suppose if the current index character is not equal to the last index character, then what we will do, we will update our last pointer to current one, because we need to just keep check of we need to just keep checking the last index that we have traversed, and the index that is different from our current index. Okay, so we will update the last pointer to I if the character are not equal. So we will just say last is equals to I, and we will move to the next index. Suppose this is our last index, this is our last index, and this is the position where I am standing it. Okay, so let's say this is last index and this is ith index. Okay, and suppose these two characters are same, then we will check uh, which which pointer is pointing that has less needed time in between the two pointers. Okay, so here as we can see, the last pointer pointing to this position has less needed time to remove than the pointer at and the pointer I is pointing to. Okay, so we will remove the character present at last pointer. Okay, so and we will add the time needed to remove this character in our answer variable. Okay, so we have removed the character pointing by last pointer. Okay, now we will update the our last pointer to I, because we have already removed this last pointer character. Okay, now we don't have any character at that position, so we will update our last pointer to I. uh, like this we will do traversing until we reach the end of the end of our string. Okay, so this is the whole approach. Actually, I have already solved this problem using iterative approach. uh, I guess I can solve this problem using recursion. So now let's solve it using recursion. So I need to have one last pointer that is pointing to the first position initially, and I have also needed to get one point one current pointer that is pointing currently to the index that I am standing on to. Okay, and I will create one uh, recursive function that will return me the time that is needed to remove the minimum time that is needed to remove the all the consecutive balloons with same color. Okay, so and this function will take parameters as vector of colors. Let's call it as cold, and it will also take the time vector, and it will also keep check of the last pointer, and it will also, yeah, it will also take the current position, and it will take the size of the array. Okay, okay, so actually the color is string. Okay, so I need to give it a string. Okay, so suppose what will be the base case for this recursive function. Suppose I have reached the last position of the array, so I will just return 0 in that case. Okay, so it should be n, and I will just return uh, 0 from here, and mm, okay, suppose colors of sorry, if color of I is equals to color of last, then what we need to do, we need to check if the time is which time is less. Okay, time for removing which character is less. If the ith character is taking less time to remove comparison to the last character, then we will remove the ith character, and we will call the, okay, if it is, okay, um, color, okay, color I is equals to color last. Okay. If it is less, then we need to remove the ith character. Okay, let's take one answer variable that will give me the answer that we have needed to remove all the consecutive element with same color. So if my ith character is taking less time than last character, then what we will do, we will remove the ith character and we will add the time in our answer. Else what we will do, we will remove the last character and we will add the time in our answer variable, and we will update the last pointer at I, because we have already seen that if we have removed the last pointer, then last pointer character, then there is nothing at the at that po- uh, at that index. Okay, so we need to update it to our current position. So suppose if this condition is not true, then we will need to update the last pointer to our current position, because we only check the if the two characters are not equal, then we already know that it will be there will be some gap uh, after coming that will between two balloons. Okay, so we will just change it to our current position, and from here we will call again our uh, recursive function uh, for next index and answer it is okay, and integer answer, and we will call the function, okay, yeah, and from here we will return the answer. Let's just see if it is running or not. Okay, and we need to define so n will be colors dot size. Okay, mm, okay, it is coming as expected, so let's just submit it. It is taking much time uh, in comparison to the recursive function, because we keeps calling the fun this recursive function, uh, and it will create some call of stack of calls. Okay, yeah, so it will take some more time than this iterative one. So let me just show the iterative one also. I have already done this. So I have just taken the first position as last one, and as the size of the this colors, or we can say time array, and one answer variable to hold the answer, and from 1 to last index we will go and we will check if the colors I is equal to color last, then these two characters are same, then in that case what is the what is the position from which we have to delete the character, and after deleting we need to just add the time to delete that element, that balloon. Okay, else what we will do, we will just update our last pointer to our current position, and in the end we will just return the answer. So that is all the iterative approach. So I will update my GitHub repository for this problem, so you can find the both iterative and recursive solution there. Actually iterative and recursive solution are already like logic is almost same, almost means logic is same actually, but this is a recursive approach and that one was iterative one. So yeah, that's it for today. If you like if you really find this video helpful, then you can like and subscribe to the channel. Okay, yeah, that's it. Thank you.